Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, that is problem 2389, longest subsequence with limited sum. So in this video, we're going to provide or share a solution format based on partial sum and binary search. First, I'll read through the main statement of the problem, and then we do the analysis, and finally we share the code and analyze it line by line. So first, let's look at the statement. So we are given an integer array called nums of length n and an integer array queries of length m. So we are required to return an array called answer of length m, where answer I is the maximum size of a subsequence that we can take from nums such that the sum of its elements is less than or equal to query I. So this such that actually is the main requirement in this problem. So the next paragraph explains what's a subsequence. So this is very standard, so we're not going to read through. So let's look at the examples. So we're going to look at example 1. So in this example, so the nums is 4, 5, 2, 1. Notice that the nums array is not sorted originally. So the query is 3, 10, 21. So let's look at the first query, 3. So the output is 2. So for the output 2, it means that we can choose at most 2 elements from nums array so that their sum is no greater than 3. So here actually we can take 2 and 1 or 1 and 2. So that's example 1. So let's also look at the constraints or additional assumption for this problem. First, n and m is bounded above by 1000 and the elements is in a range between 1 and 10 to the power 6. So that's the main statement and assumptions for this problem. So now let's look at the method and analysis. So our solution is based on partial sum and binary search. The procedure actually is very straightforward. So first, sorting is important for this problem. So because we'll try to fetch from small to large. So after sorting the nums array from small to large, so we compute a partial sum array. And then we are going to use binary search to locate the index left to which the partial sum is less than or equal to a reference value from the query. So that's the high-level overview. Let's look at one example. So that's corresponding to example 1. So this nums array after sorting is 1, 2, 4, 5. And then the partial sum array is very easy to compute. That is 1. So if we add 1 to 2, we get 3. If we add 3 to 4, we get 7. And if we add 7 to 5, we get 12. Then for a query value, say 3, we can check an insertion point using binary search. So for example, for 3, we get insertion point is 2, index 2, which means that so to the left, all the partial sums are less than or equal to the query value. So because the index is 2, it means that so we can pick at most 2 elements. So in this case, we can take 1, 2 from the nums array originally. So we can also check for query value 10 and 21. For 10, the insertion point will be 3 here, and for 21, the insertion point will be 4. So 4 is the length of nums array. So in other words, it means the sum of nums array is less than or equal to the query value 21. So with the walkthrough covered, let's look at the code. So the code actually is very short if we use some pre-implemented binary search function. So actually, if we implement from scratch, it's also an easy task. So for this, actually you can or you are welcome to check the corresponding playlist in my channel. So for this, we have imported this function we're going to use. We're going to use binary search right according to this sentence here. So first, we are going to do some preparation. So for this, first I'm going to track the length of nums array. And then after that, let's first do nums sort. So we're doing the sorting in place. And then we are going to compute per sum. Compute the partial sums. So for this, actually we can start from index 1. So for range 1 to n. Then what we are going to do is update the current value by adding the previous partial sum, that is nums I minus 1. So with that done, so we are ready to prepare the result. So prepare the return. So for this, we're going to initialize a result variable. So this result variable is going to hold the corresponding entries we are going to add based on the query. So basically, it's a for loop for s in queries. So we're going to locate the index, that is bisect right. So we're going to search insertion point in the partial sums list. So notice that the current state of nums is not the original nums array. It represents the partial sum. So then the value we're going to search for insertion point is s. After we get the insertion point, so we're going to append the corresponding IDX into the result variable. And finally, we return the result variable. So that's actually a full solution to this problem. So this problem is marked easy in Leetcode, but it's actually a very interesting problem. So let's do a special case check first. Yeah, it passes a cooked up example. So we're going to check if we have a large number. So this result should be equal to the length of the nums. So let's do a generic case check. Yeah, it passes all the generic cases. So you can check again. So this should be reasonably fast, I want to say. So with that said, I guess that's about it for this problem, for this solution. As we mentioned, the main ingredient is a partial sum after sorting and a binary search. So with that said, I guess that's the end for this video. Thank you very much.